In section 10.3, we're going to look at areas of regular polygons. Now this process isn't going to seem easy at first, but there are a few basic steps that we're going to follow with these. We do have a formula, but to plug the values into the formula, you're going to have to do some work to find the values that you need. And so there's some things that we'll have to understand about these. Now first of all, a regular polygon meant that all of the angles are the same and all of the sides are also congruent. Now any regular polygon can be inscribed inside of a circle, so all my points end up being on the circle. And even when we get really big, it starts to look like a circle, but these are flat sides. Now we can also draw from the center of my circle the segments, the radii connecting out here, and those will form angles inside the middle as we see down here. Now notice if I have a triangle, that forms 3 triangles or 3 angles in the middle. A hexagon has 6 sides, it forms 6 triangles or 6 angles in the middle. And so we can find the measure of each central angle by dividing by the number of sides. So in this triangle, those central angles will be 360 divided by 3, 120. Or a hexagon, 6 sides divided by 6, we get 60. If we have 20 sides divided by 20, we get 18. And that's going to be our first step in finding these. Now this is the formula that we have, and it's based on the fact that there are a number of triangles in here, so we can use the perimeter of the whole thing. But we have to know what this little a is. A is called the apothem, and it's the altitude of just one of our triangles. What we're doing is we're sort of focusing on just one of the triangles that's formed. And notice I could multiply that by 5. Now the perimeter would also be, if we take one of our sides here, the perimeter would be equal to 5 of those sides. So it's kind of like taking 5 triangles over here, or however many sides we have in our regular polygon. But this is the formula we're going to use. The main thing is remembering apothem means center, perpendicular to a side, and P means perimeter the whole way around. So to find the area, the first step is usually going to be just to find this central angle. Now I have 5 triangles here, so I divide by 5. I started really by sketching these radii going out, connecting the center to my vertices. And so I know that that's 72 degrees because I have a pentagon here. Okay, that's my example. But this will work for any shape. If it's 10 sides, we plug in 10, and so on. In my second step, I need to find this angle right here. Okay, the reason we're finding that angle is we're going to be able to use sine, cosine, and tangent, which is our next step. So to do that, we know that since these are isosceles triangles, because they're all a radius of our circle, so we can just divide it by 2. So if this one was 72 degrees here, we divide it by 2. This little angle here would be 36 degrees. That helps us because now we can use trigonometry to find our side, or if we have the apothem, it'll help us to find parts over here. After we find the parts that we need, we can plug them into the formula. Okay, let's look at one here. We've already done the first couple of steps with this pentagon, and we found we have a 72 degree angle, and that gave us this 36 degree angle in this part of the triangle. What we're focusing on is this little triangle here. So our third step, the trigonometry, this is where you're going to have to think, and this is where each problem is going to be different depending on the situation. This is why I want you to draw the pictures so you can see what you actually need. In this problem, I'm giving you the perimeter is equal to 45. I use the fact that it's a pentagon to divide that by 5 and find the length of each side. To find the apothem, then I need to know about this right triangle. That's always going to be half. That side there will be half of that 9, giving me 4.5. Now I can solve for that using the tangent. Plugging in, that gives me 6.19. I know that my perimeter was 45 because it was given. I've just found my apothem using my formula with tangent here at 6.19. So I can plug that into my formula. Perimeter is 45, apothem, area equals 1/2 PA. And that gives us a value as inches squared. So let's look at this example. We have a regular decagon. That will be 10 sides. Now notice what's been given to us. This time we're given the apothem, so we want to pay attention to that so that we know what we're actually looking for. We're looking for the perimeter, which means we're going to need to find the lengths of the sides. It also means we're going to be looking, remember, at this triangle here, and we only want to look at part here, so I call this x. That's only half of our side. So our first step, the measure of the central angle. Again, 360 degrees. And since it's regular, we can divide that into 10 triangles, which is 36 degrees. If we're looking at each one of these triangles going around, that would be 36. But this one here, that would only be half of this, so we're going to divide that by 2. Now that gives us 18 degrees for this angle. Now let me redraw this triangle a little bit bigger so you can see it. So this side was 12.3. We just found this angle to be 18 degrees, and we're looking for this side x. So we're going to use trigonometry to find that missing part. This would be the tangent. So the tangent of 18 is equal to x over 12.3. And that will work out to about 3.9965. So we're just going to round that to 4. Now again, we were looking for the whole side. So if x is just 4 here, that would mean our whole side would have to be 8. We have 10 sides there. So that 8 times 10 is going to give us a perimeter of 80. We'll now use our formula, 1/2 PA, and plugging into that formula, we'll get 80 times 12.3, and that comes to 492. Don't forget your units, that's in square inches. So again, remember, just take these steps one at a time, and remember your formula, and you should be able to work through these. Mostly you need to practice on these to know how they work. One note that I should make here is that we want to use the easiest method. We don't want to make these more complicated than they have to be. So if I have a problem like this square over here, I could use 1/2 PA, where I would have to find this side. Notice that if this is 8, then the whole side would have to be 16. But if I know that this is a square and that side is 16 and this side is 16, then the easiest formula would just be length times width, or 16 times 16, which gives me 256 inches squared. Also, for this triangle over here, if we have a side of 8 and I have an equilateral triangle, then I know these are 60-degree angles. I could easily find the whole height of this. This side here would be 4. The whole height would be 4 square root of 3, using the 30-60-90 ratio. Notice what I have right now. I could just use my regular formula for the area of a triangle, 1/2 base times height, where my height here is the 4 square root of 3. My base would be this whole side here, which is 8. So I'm just going to use 1/2 of 8 times 4 square root of 3, which gives me 27.7 inches squared. So again, use the easiest method. Don't get drawn into the more complicated ones when we don't have to.